Okay, just going to continue going through some requests from exercise 11e. We've got question 3 part C. We have to integrate root x squared plus 4 over x with respect to x. We have to use integration by substitution, but they don't give us the substitution. So looking at this, I can see potentially two options. So I'm thinking either u is equal to x squared plus 4, the thing inside the square root, or u is equal to the square root thing itself, x squared plus 4, like so. Let's try them both. They might both work, or maybe one of them works. Let's see. So this first one, du by dx would be 2x. And if you make dx the subject, you'd get 1 over 2x du. And then call that integral. I would be equal to square root of u over, again, it's not easy to make x the subject because I'd have to square root, and when you square root you do take plus or minus, so I'm not going to make x the subject yet anyway, so leave the x in there, times dx, which is 1 over 2x du, which is equal to integrate root u over 2x squared du. Still got an x in there, but you can make x squared the subject. If you made x squared the subject, you'd get x squared is equal to u subtract 4. And this is equal to integrate root u over u minus 4 times by 2 du. Now, not 100% convinced this is any easier than the integral we started off with, this one. Things you could do, you could write that as u to the half, 2u minus 4 du, but don't really know what to do after that. You can't write this as separate fractions because the numerator is by itself. So I'm going to go to the other option, this substitution. And this one, before I differentiate, you need to write it in index form. Now I have to use the chain rule, something to the power of a half. So du by dx, bring the power down, knock one off the power, and then chain rule says times by the bracket differentiated, so times by, in this case, 2x. And that instantly simplifies. So du over dx. Now, they tend to prefer, as you can see, square roots. So I'm going to rewrite this as x over root x squared plus 4. And then make dx the subject. So if you made dx the subject, you would get root x squared plus 4 over x du. Okay, call that integral I again. I is equal to integrate root x squared plus 4, which I'm calling u, over x. Again, it's not easy to make x the subject, so I'm going to leave it in there, x, times this, which is root x squared plus 4, which is u again, u over x, du, which would be the same as integrating u squared over x squared du. Okay, we've still got some x's in there, but you can make x squared the subject pretty easily, so that is the same as u squared equals x squared plus 4. X squared would be equal to u squared subtract 4. Yep, u squared equals x squared plus 4, x squared equals u squared minus 4. So let's do substitution. This is equal to integrate u squared over u squared minus 4 du. Right, what to do next? Again, this is, for some reason, they're asking you to do stuff which is in a different subchapter. This is 11.7 partial fractions. And, okay, so with this one, you've actually got to use long division for this. So you got u squared divided by u squared minus 4. This is called an improper algebraic fraction. And if I divided u squared by u squared minus 4, like so, I'd have 1 u squared plus 0u minus 4. Do the subtraction, first column disappears, 0 take away 0, obviously 0, and 0 subtract 4 is a plus 4. So you've got a quotient and a remainder. So this is equal to integrating quotient plus the remainder du. And I believe, just double check, that's almost exactly the same as what we have to integrate in question 1 part D. 4 over u squared minus 4. 4 over u squared minus 4. So we have to use partial fractions again. So it's integrating 1 plus, if you remember the partial fractions from before, 4 over u squared plus, 4 over u plus 2u minus 2, or u squared minus 4, what we've got, we had a would be minus 1, b would be plus 1. So minus 1 over u plus 2 plus 1 u minus 2 du. Again, this is a different subchapter, still 11.7. Don't worry if you don't know this yet, but integrating this would be going to u minus ln u plus 2 plus ln u minus 2 plus c, which is u plus ln u minus 2 over u plus 2 plus c. And if you want everything in terms of x, it'd be root x squared plus 4 plus ln root x squared plus 4 minus 2 root x squared plus 4 plus 2 plus c. So yeah, again, for some reason they're asking you questions with which require integration by not only by integration by substitution but partial fractions as well. But we'll do more of that in 11.7.